Welcome to GEOG485 585L, Internet Mapping, Module 2.3, Web-Based Mapping Clients, OpenLayers JavaScript Framework, Part 2. This week we will continue our discussion of the OpenLayers JavaScript Framework with a more detailed discussion of the options related to creating a map object in OpenLayers, additional detailed discussion of layer object options for the various layer types that can be created, and then a discussion of some additional layer types with examples and sample code. So when we're talking about the options for the creation of the map object, you can go to the API reference as the first source of information for the current set of options available for the map object. A link to the API is provided here. We can click on that and see all of the options that are available for the OpenLayers map object. Only some of which will be discussed here. But if you're looking for the official complete documentation, you can find it here. You can also find it in the OpenLayers 2.10 book that we have as one of the texts for the class. Overall, when you're creating new map objects, there are two primary methods for creating a new map object. The first is the very simple one illustrated here, where you essentially just create a map with the default options, essentially accepting the default values for all of the potential options for a map object, and just create a new map variable that is a new OpenLayers map object, where you refer to the document object model HTML element that you have given an ID to that you refer to here. So if we look at the HTML document that contains the map client that we're designing, we will find a div with an ID of map1, which is what this particular map object would be attached to, and where the map content that this map object will manage would be displayed. Another method is to specify one or more non-default options as a part of the creation process for the map. And in the example provided here, you can see we've actually gone through a two-step process, very much like we did when we looked in the Google Maps examples earlier in the semester, where we have created a variable that is a dictionary of name-value pairs, where the name-value pairs correspond to an option name and then the value assigned to that option, and then another option name and another value, so on and so forth. Where this list of options is assigned to a variable called options, which you can then use when you create your new map object. Here, the syntax is very similar to the first example we saw, with the addition of there now being this second parameter that is provided as a part of the OpenLayers map creation command. So if you provide no options, you are basically creating a map object with the default values. But you can provide additional options either directly or through reference to a variable, as we've done here. A third option is to actually create a single argument that includes the pointer to the div that will contain the map and all other map options. And you can see that in the third example here, where instead of essentially inserting right after the opening parenthesis for the OpenLayers.map command, the identifier, the ID of the div that we want to attach the map object to. Instead, we can just include that piece of information in with the other options as a part of the set of options that are specified for the layer, or for the map, I should say. So in this case, we just have an option here named div, which is the equivalent of the previous two examples where we just provide the ID of an HTML element that we want to connect the map object to. So this is just an alternative way of specifying the map object, where the div that it's going to be attached to is just one of the options that are provided as a part of the creation of that map object. If we look at the API documentation, there is information about a wide number of options that are available when creating a map object. And I've excerpted a number of them from that API documentation to show here. Though I really only want to hit some of the highlights as we go through these, since you can go to the documentation yourself and review these as you need to. A couple of the first options that you want to be aware of is this all overlays, where you can actually just specify for the entire map that all layers that will be added to it will be overlay layers. There will be no base map layers, which is in contrast to the exercise you went through last week, where some of the layers that you added were base map layers and some of them were overlay layers, or they might have all been base map layers as you did your exercise. All overlays allows you to define at the map level that all layers will be overlays and therefore can be turned on or off by the user. We've already seen the div option as a way to specify the document object element that the map object should be attached to, as an alternative approach to linking the newly created map object to the rest of the HTML document that contains the map. You can specify within the map object itself the layers that are a part of it, or as we've seen in the example so far, we can add those layers iteratively. But if those layer objects have already been created, you can specify them as a list of open layer objects, layer objects that you can specify as an option for the map object. You can modify the default size of the map tiles that are used. You can define the projection of the entire map, keeping in mind that the default value, if you do not specify a projection, is EPSG4326, the common WGS84 coordinate reference system that we have been using for many of our online mapping applications. You can specify the map units, where the default is degrees or decimal degrees. But you can, depending on the coordinate reference system, the projection you're using, you can specify other map units as well so that the appropriate calculations are done within the map in terms of calculation of scale and other key attributes. By default, OpenLayers calculates an appropriate set of map resolutions based upon either the default values in terms of the number of zoom levels, the tile sizes, and the extents of the map. But you can specify your own set of map resolutions in terms of map units per pixel if you would like to specifically define them, as opposed to letting OpenLayers calculate them for you. The max resolution allows you to specify what the maximum resolution would be as calculated by the number of map units divided by the tile size. So in the example here, the default maximum is 360 degrees, by 256 pixels, both of those being the default units for the map units and the default tile size for OpenLayers. This results in a default max resolution of about 1.4, which is essentially the maximum resolution that you would see in terms of essentially the entire globe fitting into one map tile in this particular instance. Minimum resolution allows you to similarly specify a minimum resolution for your map. And also you can specify maximum and minimum map scales if you prefer to work in those types of units in terms of the relationship between map units and actual physical units on the ground. You can also define the maximum extent for the map, where by default, the maximum extent defaults to the entire world. But if you only want your mapper to focus in a particular area, you can actually create an OpenLayers.bounds object that defines the maximum extent that the entire map should be limited to, where this would essentially not allow the user to zoom or pan outside of the region defined by that max extent. The minimum extent, or min extent, is what it sounds like, where this does not allow the user to zoom any further in than this minimum extent is defined. Restricted extent is another way to actually limit map navigation, where you can then control the zooming to a resolution that will still restrict them to a particular area within the map. The number of zoom levels, or num zoom levels, defines the number of essentially increments that are on the zoom control, where this value defaults to 16 zoom levels, but you may find in some circumstances that you want to modify this. And actually, one of the examples that we will look at later in the lecture illustrates this. As we move on to the layer object and the options related to creating new layer objects, we can think about a common pattern for the creation of layer objects and where the various options fit into that pattern. If you would like to see a full list of the layer object options, you can click on the link in the slide that will take you to the API reference for the OpenLayers layer object. And you can see the various properties here that you can set as options when you're creating your layer object. The typical pattern for layer object creation, which does vary from layer type to layer type, but this is sort of an overall pattern that is fairly common, is really 4 elements that you are providing to the layer creation function. The first is nearly always the name of the layer. This is the name that will appear in the layer picker and may be available to you for request or display in other map elements. If the layer has a uniform resource locator or URL associated with it, that is typically the second element in the list of elements that are submitted to the layer creation function. The third element, again, depending upon the particular layer type, but if there are options that are specifically related to the server that OpenLayers is interacting with, say a web map server, it's in this third element that you can provide a list of name-value pairs that correspond to the options that you would submit to the server that is hosting the layer data that you're retrieving. That's in contrast to the fourth element of this list, which is essentially the options that relate to the layer object itself. And it is these options that we're focusing on here in terms of just a quick overview of what those options consist of. So as you're trying to figure out what information needs to go where, remember, typically, the first item is going to be the layer name. The second item will be the URL for the layer as you're requesting it from the remote server. The third item will be the set of options that are submitted to the remote server, which gives you an opportunity to modify the request that is being submitted to the server on behalf of your mapping client by OpenLayers. And then the fourth element is the list of OpenLayers layer object options. Some of the OpenLayer object options that may be of interest to you as you're creating new layer objects include providing an ID for the layer itself, which if you're writing JavaScript code, you can then access these layer objects by ID. The name is another way of representing the name that you're assigning to the object. So that's an option that can be provided as well. As you saw last week, there's an isBaseLayer Boolean option that allows you to define whether or not the layer that is being defined is a base layer, and conversely, if it's not a base layer, it's treated as an overlay layer. There's the option to display in the layer switcher, which is a way to essentially suppress the display of that particular layer in the switcher where the user could select either the base layer or enable or disable the layer if it's an overlay layer. But this is a way to either hide or explicitly show the layer in the layer switcher control. Visibility, on the other hand, assumes that the layer is displayed in the layer switcher, or that you do not want to display the layer at all. So if you set the visibility to false, that means the layer will not be initially displayed when the map loads. It will still be available in the layer switcher and can be turned on in the layer switcher if you allowed it to be displayed. If you have both display in layer switcher set to false and visibility set to false, that particular layer will never be displayed in the map unless you write some other JavaScript that would change one of those two values. Attribution is an attribute that you can set, which is just a string, that allows you to essentially provide credit to the source of the data that are associated with the layer. Many data sources or data providers have a requirement or a recommendation for attribution to their service as a requirement for being able to use that service. This is where you can place that attribution information, and there's then the attribution controller, which is by default enabled within the OpenLayers map, where this information is displayed. And it concatenates the attribution information for all of the active layers into that attribution control. The projection option allows you to set the map projection for that layer, essentially overriding the default projection for that layer. So this is a way to actually, at the layer level, define the projection for that layer, keeping in mind that if you set the layer projection to a projection that is incompatible with the map, you may actually not see the information from the layer, the data from the layer appearing in the proper location within the rest of the map or in relation to the other layers that are within the map object. You can also specify the units for the layer itself. So if you have a layer that has map units that are in meters, feet, kilometers, miles, or inches, you can specify those directly in contrast to the default value of degrees. So if the map units are in some other unit, you can specify that. That's important for being able to properly calculate the map scale that is associated with that particular layer. You can also set a series of map scales where these values are relate to, again, the map scale denominator. 1 to 10,000, 1 to 24,000, 1 to 100,000. So those would be 10,000, 24,000, or 100,000. And this relates to the information being displayed to the user. Resolutions is another way of setting the resolutions available for this particular layer. So you can set these separately for each layer if you wish. Otherwise, they will be based on the other characteristics of the map itself or the max and min extent and max resolution values for the layer. So you have then the ability to set the maximum extent, which can be used to change the area over which the data will be displayed. If the request for a particular map falls out of that maximum extent, data will not be requested from the service for that particular layer. Similarly, the minimum extent can also control when or how data are requested from the server. The max resolution allows you to specify different resolutions that are available for that particular layer, also ultimately controlling whether or not that layer would be rendered within the overall map. If the resolution of the map exceeds the max or min resolution settings, the layer will not be displayed. Just as at the map level, you can also specify a number of zoom levels for an individual layer object. And this, along the lines of the min and max scale options, allow you to define values that will basically trigger whether or not a particular layer will be requested and displayed based on what the current zoom level is, whether it is within or outside the range of the number of zoom levels defined, and the minimum and maximum scale defined for the layer. The display outside max extent option basically toggles whether map tiles that are outside of the max extent should be requested. This is a variation on caching data, but since they are typically outside the maximum extent, the reasonable default value is false, and you will find very few situations where you would want to change that to true. Transition effect allows you to use a computationally more expensive but possibly more visually exciting transition when the map is panned or zoomed, where the default value is no transition effect. Essentially, the map is just moved from one place to another, or moved in and out in terms of zooming. But you can also choose a resize transition effect, which creates a zooming visual effect, which in some circumstances could be useful, but it's a little bit more computationally intensive within the web client. And as a result, if there's not a compelling reason to add this transition effect, you may not want to incur the additional cost to enable it. So these are just a few of the options for the map and layer objects, but there are some additional functions and events that you should at least be aware of, and that you have seen in the textbook, and if you've been looking at the API documentation as well. But these are capabilities that you should keep in mind as you contemplate building your own OpenLayers mapping applications. First, as you write your JavaScript, or as you add new controls, whether they're buttons or other capabilities to your mapping client, each one of these map and layer objects have a set of functions for both getting the properties from those objects so that you can learn what they are, and then you can also then modify those properties using a variety of set functions. So for each one of the properties, there are typically a get function and a set function, so you can read the information, and then if you would like, modify a property after the object has been created. This allows you to add a more dynamic character to your web mapping application, as you can essentially change the client on the fly. You can also completely destroy and reconfigure maps using the JavaScript controllers associated with the map objects. And then both layer and map objects have a whole collection of events. As we saw when we were creating the pop-up text boxes for Google Maps, and we were essentially linking some Google Maps functions to the events that were associated with the features that we had in our Google Maps. We have a similar set of object events that OpenLayers can take advantage of for executing particular JavaScript functions in response to different types of interaction with map or layer objects. So again, if you're developing a custom web mapping application, you will probably want to look at the various events that are available for and triggered by interactions with these objects, so that you can know essentially what hooks you might have within the application for being able to trigger additional JavaScript functions. These are all beyond the scope of what we're covering in this class, but it's good to be aware of the fact that these additional capabilities exist, so that as you move forward and you want to look at more advanced functionality, these are some capabilities you should be looking for. Let's now look specifically at the creation of a web map service layer, and how we go through the process of configuring a WMS layer within OpenLayers. So just as with the options that we were looking at for the map object and the layer object, a core reference is the API reference, in this case for the WMS layer class, which we can just click on the link in the slide, and this will bring us to the set of options for the WMS layer. Keeping in mind that the WMS layer inherits additional capabilities from this OpenLayers.layer.grid object. So you can see that there are some additional properties that you can set here that are associated with the grid. And then you can also then see that these also then inherit from the OpenLayers.layer HTTP request. So there's an additional property that you can see here and some additional functions. And finally, they inherit from the OpenLayers.layer object. So as you're reading the API and you're looking for the options that are available for any of these different layer types, they are typically nested in that they start with, in this case, the properties and capabilities of the OpenLayers layer object, and you can see all of these options here. But then as you go through the more specific layer types, again, coming back down eventually to the WMS type, you have this accumulation of properties, all of which you can potentially select. So what we have here is some information and an example of a very simple creation process for a WMS layer object. When creating a WMS layer object, there are some key things that we want to keep in mind. The first, and possibly most important, is that the projection of the map object that you've created previously must be supported by the WMS service that you're communicating with. And this is where you should remember that you can see all of the supported spatial reference systems or coordinate reference systems by a particular web map service by reviewing the get capabilities XML file that is delivered by the service. So the practice that you were doing before in looking at and evaluating the content of a WMS get capabilities request is key in getting the information you need to make sure that a WMS layer that you want to add to your map will actually be compatible with that map in terms of the supported coordinate reference system or projection. You must also provide the layers parameter as a part of the server related properties for the configuration of the layer, where at the very least you have to specify to OpenLayers what layer or layers you want to be included in the WMS request. Remembering again that the layer names also come from the get capabilities response from the service. Finally, you can provide other WMS parameters such as transparency, such as version, such as format, that you can use to specifically define what those values are as an alternative to using the values that OpenLayers automatically provides as a part of those requests. So if you are not satisfied, or if for some reason you need to directly specify transparency or the WMS version or the format of the images that are returned, you can specify them explicitly within the server interaction parameters or options for the WMS layer. And we can see here an example of creating a new WMS layer object where we are basically creating a new variable. In this case, is called counties layer, and we're defining it as a new OpenLayers.layer.wms object. We're giving it the name of US counties. So this is the name that would appear in the layer picker. We're specifying the URL. This is the base web address for the web map service. Just as we've talked about previously, the information that is provided in the get capabilities request in terms of the base request to which you would add the additional WMS specific request parameters. Here we're defining a set of WMS server specific parameters, where in this case you will always need to provide a layers parameter. So in this case we are specifying that we want the counties layer from the WMS service, And just as with WMS, we can provide here a comma-separated list of layers, and you'll see an example of that in just a moment. Here we're also explicitly defining the version of WMS that we want to use, and explicitly defining that we want transparent to be true. So in this case, while OpenLayers may request a transparent image anyway, we are explicitly defining it here. And we are here also then providing a single OpenLayers option where we're saying is base layer is false, meaning that we want this to be treated as an overlay layer, a layer that the user can explicitly enable or disable using the checkbox in the layers picker. So if we look at a complete example of a map client that contains more than one WMS service, we can click on the example link here. And you can see here that I actually have a number of layers included in this particular map service. I have 3 overlay layers and actually no base maps. And you'll see how I did that in just a minute. But by looking at the map, you can see that we basically have a background image that's based on some satellite imagery. We have then a U.S. counties, an Indian lands, and a U.S. federal lands layer. Each one of these are being provided by a WMS service. So we essentially, in this case, have 4 WMS layers that are a part of this particular mapping client. And as I zoom in, you can see that the imagery is re-requested from the web map service each time I zoom or pan. And then I can turn, say, the counties layer on again. And so now I just retrieved again the image of the county boundaries from the web map service, in this case from USGS. So let's take a look at the source code. For this particular map client, where we have our, standard information at the top of the screen, at the top of the client. You can see here that we've included the OpenLayers JavaScript. And then we have a second script, which is really where the heavy lifting is done for this particular client. And this is the script that starts right here, where first, again, I'm defining a set of global variables that include the default zoom level and where I would like the map to be centered, where I use these variables later when I define the center. I then start to define the initialization function, here called init. And this is, again, just as we've seen in all of our other examples, this is the function that defines and creates our map object and all of our related layer objects. So we first see that I'm creating just a plain vanilla map object with no specific options. I'm happy to go with the default projection of EPSG4326, and the default zoom levels will work fine for me here. I don't have any reason to change the maximum or minimum extents or to set any of the other options. So this is just a very basic map. Now, let's look at this first WMS map layer. I am assigning it to a variable, in this case called BMG layer, BMNG layer. And I'm creating it using this new OpenLayers.layer.wms function where I'm defining the name of this layer, the base web address for the web map service that is providing this layer, and then the block of parameters that I want to specify for this particular WMS layer. Where here you see an example of setting the layers parameter to a comma-separated list of layers as opposed to just a single layer, and that's entirely valid. Just as you can compose a WMS request that you would type into your browser that can include one or more layers separated by commas with no spaces. You do not want to have spaces between those comma-separated values, otherwise it will be an invalid request. You can then get all of those layers returned as a single map image. Also remembering that the order of the images or layers that you request from the web map service does matter in terms of the way they're stacked. In this case, this particular map service has scale limits assigned to many of these map layers, so they will automatically toggle on and off depending upon the scale of the request that has been submitted. You can see I have also specified here the WMS version and that I would like the returned map image to be true, or I would like the returned map image to be transparent. I then have some additional OpenLayers options that I'm setting here as well. Noting that there are commas separating each one of these elements. So we have the name and a comma. We have the URL and a comma. We have the server options and a comma. And then we have the OpenLayers options. Where in this case, I have specified some additional options where I'm specifying this as a base layer. So it's treated as a base layer. I'm setting display in layer switcher to false, which is the reason why this did not show up as a base layer in the layer picker. And then I have also added an attribution string to this, which automatically appears in the map client, in that attribution control. So after defining all the characteristics of this new OpenLayers.layer.wms object and assigning them to this variable name, I then execute the map.addLayer, specifying the variable that represents that WMS layer object that I just created, and we've now added that layer to our map. We can now repeat that process for our 3 other WMS layers, all of which in this case come from the USGS National Atlas, and you can actually copy and paste this URL right here to get information at least about the boundaries WMS service. But if you just go to the higher level National Atlas, you can see some of the other WMS services that are hosted by USGS that you may want to integrate into your map services and applications. So just as we did with that imagery service, we're creating a variable. In this case, it's called counties layer. We're creating a new WMS layer object with the name of US counties, the base URL for the service, the WMS options, which in this case, it's just the single counties, version 1.3.0, and transparent is true. And then the OpenLayers options, only one of which we're providing here, where we're defining that this is not a base layer, so it will be treated as an overlay layer. And then we are adding that new WMS layer object to our map object. So now we have two layer objects that are a part of our map. We now have the next USGS layer that I'm creating in a variable called endLand layer. And this is another WMS layer object with the name of Indian Lands, the base URL from the Gate Capabilities request, the WMS information. In this case, I'm requesting again one layer, the endLand layer, specifying the version and the transparency. And then here, the OpenLayers options, where I'm again specifying it as not a base layer, so it's going to be an overlay layer. And I've also here specified visibility false, meaning that this layer is not enabled or visible by default. But since it will be displayed in the layer picker, the user can turn it on when they would like. This is a way to add more layers to your map than you might want to have initially displayed, providing the user with the option of being able to turn them on or off. Also, you can use JavaScript to provide other controls that might turn those layers essentially on or off by toggling this visibility option for them. In this case, we're creating the layer, but it is not visible, but it is available to the user. And then we add this newly created layer to our map object. So now we have three layers that are a part of this map object. Finally, we're adding our fourth WMS layer that we're creating in a variable called Federal Lands Layer. It's a new OpenLayers.layer.wms function where the layer name is US Federal Lands. The base web address is here. Our WMS options are here, where our layer in this case is Federal Lands. We're also specifying the version and the transparency. And then we're specifying our OpenLayers options, which again, setting the visibility to false for this layer, so it is also not displayed by default when the map loads. After that WMS object is created, we then add it to our map, creating our complete set of 4 layers. As we saw in our previous example, we're now setting the center of the map at our previously defined latitude and longitude and zoom values, which are defined in the variables up above. So I don't have the numeric values for the longitude and latitude and zoom here. Instead, I'm referring to the global variables that were defined up above right here. Again, providing a way to have reusable values that you can refer to by name elsewhere in your JavaScript. So you're not having to search around if you want to change what your initial map center and zoom are. And then finally, in addition to the default controls, I'm adding an additional layer switcher control so that the user can selectively enable and disable the layers that are a part of the service. And that is the end of the initialization function. And if we look at the rest of the HTML page, it should be fairly familiar to you by now, where we also have a small style block for a production mapping application. I would actually store my styles outside of the document itself, but for illustration purposes, I'm providing a CSS style as a part of the head of this document so that it is all together in one page. And in this case, I am just specifying 2 attributes of the map object. This is the object that has the map ID. setting it to 90% of the width of the current web page and the height at a fixed height of 500 pixels. Remembering again, if we now look at the body, when the body has finished loading, this onLoad event is triggered, which then executes that init function that creates our map object and all of its layer objects. I have some basic text here as a part of the page. And then I have the all-important div with the ID of map that corresponds to the div that is identified when we created the map object up above. And then we close the body and the HTML. So now we can come back to the client and you can see how this is played out in the client as a whole, where the background imagery is that satellite imagery, and I can turn on and off the individual WMS layers. As I zoom in, those result in new WMS requests that are submitted to both the imagery service that we are hosting here at the Earth Data Analysis Center and at USGS for all of the other layers. You can see, though it's not very clear here, I've actually styled it a little differently in the other example. The attribution information is right here. This is the default location for the attribution object within the OpenLayers client, which in your own map applications you may want to change. And I have an example of how to style it a little differently so that it is both more visible and less obtrusive. So that completes our example of how to go through the process of creating a map that contains a set of externally hosted WMS layers. Now let's talk about the configuration of vector layers. This is analogous to, again, some of the work that we did working with Google Maps in terms of creating either our own custom features within the JavaScript itself, or also referring to external sources. Vector layers are very powerful within OpenLayers because they allow you to access external data in a wide variety of supported formats for both reading and writing. So if we click on the link here for the formats, we can see that there's some base information here, but then also, if we click on the format link here, you can see these are all of the different formats that are supported in one way or another by OpenLayers for either reading or writing vector data. So it's a very powerful and comprehensive collection of formats that are supported by OpenLayers. As just an example, in some of the commonly used formats that you may encounter include ArcXML features, which are generated by ArcGIS Server, GeoJSON, which is a specific representation of both geometries and attributes in a JavaScript object notation. That's what JSON stands for, which is a broadly supported data exchange format that is used by many web applications. GeoRSS, which is a way to essentially publish a feed of geospatially enabled links or bits of news. GPX, which are GPS track files. JSON, just JavaScript object notation. KML that we've worked with in the past in terms of you can create a KML file and bring it directly into your OpenLayers map. WFS as another supported format which is an alternative to the WFS layer type, which is still available within OpenLayers, but deprecated in favor of using the WFS format instead. And WKT, or well-known text, which is another broadly used way of defining both a geometry, its coordinate reference system information, and any attributes associated with that geometry. So the vector layer support in OpenLayers has very broad support for a wide variety of formats that you may be able to read data and display those data within your mapping client. Similarly, if you are allowing your users to create or modify features, you can also use these supported formats to export files. So you can specify exported features to be generated in these file formats as well, to be delivered by a client. You can also directly encode geometries within your JavaScript. And we'll see an example of that in a moment. So if we click on the link here to the API reference, you can see here the set of geometry types that are supported within OpenLayers, including points, polygons, rectangles, line strings, linear rings, which are essentially single polygons, polygons, which can consist of one or more linear rings, curves, which are essentially open lines, as are line strings, but then also multi-line string, multi-point, and multi-polygon geometries that allow you to combine those into a single object that is a combination of those types of geometries. So there's a very flexible model within OpenLayers for defining geometries and rendering those geometries as a part of the map. I already mentioned the ability to actually allow users to create and edit features within the OpenLayers client. And there's actually a control that you can enable that allows users to be able to do that. And what you essentially do is you link that control to a set of features that are a part of a layer, and then they can interact with those. Those changes are not saved or stored anywhere unless you write some additional JavaScript. But it is an interesting model that users are provided with the capacity to actually create or edit features within the web environment. Finally, there's the ability to also style vector features. And there are a number of capabilities for defining what those styles are. And if we click on, again, the link to the API reference here, you can see a number of the options in terms of the symbolizer options for defining styles associated with vector objects that you might create. When you're creating a vector layer, they're typically defined using a combination of three classes. The first being a protocol, which defines the specific, essentially the web protocol or other protocol that will be used to request the data that will come from an external source. The format object defines what the format will be. Again, with that long list of supported formats available for the specification for this format object. And depending on the specific format, there may be different options. And this is where, again, going to the API reference and looking at the information for a specific format will help you in determining what the contents of this format object would be. And finally, there's a strategy object or class that allows you to actually modify two aspects of how OpenLayers works with the vector data. The first aspect is how it should request the data from the server, whether it should request all the data at once or whether it should perhaps request only a subset of data based upon, say, the bounding box of the current map area or other criteria. Also, as a second set of strategies that are available within OpenLayers, you can also define how OpenLayers handles the data within the client, whether it might cluster some of those data in terms of visualization. And you can actually apply one or more strategies as a part of the definition of a vector layer object. If we look at some examples of creating first a new very simple point feature object and then a KML layer object, we can see what some of these options look like when you're actually creating a layer. So when you're creating a point feature or another essentially geometry feature, it typically consists of 3 steps. The first is the definition of the geometry itself, where that geometry may consist of one or more points that are in a group that would then be used to construct a more complex geometry. So in this case, I'm creating a variable named coord_classroom that is a new point geometry object with these coordinates. One important thing to keep in mind is that in contrast to our work with Google Maps, the order of the points that you provide here is in the order of XY, or longitude then latitude if you're working in geographic coordinates. This is the reverse from the way we worked in Google Maps. And that might cause you some confusion if you just copy coordinates over from, say, a Google Maps client into your OpenLayers JavaScript, because you may have to reverse the coordinate order so that your coordinates come out correctly. So here, since I'm just creating a single point, I only need to define one OpenLayers.geometry.point object, where I am specifying the X and Y coordinates that are associated with that point. With that geometry defined, I can now create a vector object, where that vector object is provided, in this case, the geometry that I created previously, this geometry.point object. I could also pass another type of geometry, say a line string or a polygon or curve or other geometry type instead of this point object. But in this case, to keep it simple, I'm just passing a point object. We'll see examples of the other geometry types in just a moment. So I'm creating this new feature vector object that uses that point geometry as the definition of the coordinates. And then I am adding that feature, and you can add more than one feature at a time, and we'll see an example of that as well, to an existing layer. Where in this case, I have an array of layers that I've created called layers, where one of the layers that I've created is called local features. So this is basically a reference for a layer, a generic layer object. I'm then executing this add features function, where I'm then providing an array of feature vector objects. In this case, I only have one, but I still have to provide it as an array, and that's why we have these square brackets around this single variable that is our feature vector object. So this results in that feature now being attached to that layer and being rendered as a part of that layer. As an alternative, we can now look at how we might add a KML layer to a map in terms of creating a new vector layer based on a KML file. So in the first example, we passed a geometry to the feature.vector function to create a new vector object. Here we're creating a new vector object by specifying a KML file that should be the source of the content of that vector object. Where I'm now basically creating a new layer called layers.counties. This is another element of this layers array that I created, where the individual layer name within that array is called counties. I'm creating this new layer vector. I'm giving it the name of KML counties. And then I'm defining the options for that layer, where those options are contained within this set of curly brackets here and include the definition of the projection, which in this case is being set to the same value as the display projection of the map object. So we can just set it to the same as the map object. Here we're defining the strategy that should be used for this particular KML vector, where in this case, we're saying essentially use a fixed strategy to retrieve all of the data and manage all of the data within the client. We're specifying a protocol, where in this case, we're using an HTTP protocol, since this is a source file that we're going to pull across the internet using the HTTP protocol. When we're defining the protocol, it's within the protocol that we define, in this case for HTTP, we're defining the URL, essentially the relative or absolute location of the file on the internet. In this case, this KML file is located in the same directory as the web page that contains this JavaScript, so no other path information is required. One thing to keep in mind is that the JavaScript security model does not allow you to load a KML or other data file from outside of the same server where you loaded the HTML document from. So if you want to use a KML file, you should place it on the same server as your HTML document and refer to it in using a URL that points at that server. Otherwise, you will get a JavaScript error that you may not see, but will result in your KML file not being retrieved and not being displayed in your client. Also, as a part of this HTTP protocol, we are specifying the format, where this is an OpenLayers format object of the KML type. And here we're just providing an additional option to also extract the attributes from the KML file and make them available within the client for further use. We actually don't make any further use of them here, but they would be available to us if we wish to do so. So this is all of the information that we need to create this new layer.vector object that is populated with data that have been read out of a web accessible KML file. So once we've created that layer.vector object, we can just add it to our map, just like we do all of our other new layers by just using a map.addLayer and then the layer name, or in this case, the identifier for the counties layer within this array of layers called layers. So let's look at an example that is more complete for both illustrating the creation of vector features and KML layer objects. This is similar to the example that we used for Google Maps, in that we have essentially a base map. In this case, the base map is the same imagery service that we used in the last example, where I have added a number of new vector features to this, including 2 points here and here, the small sort of orangish circle and the larger red circle, a polygon that is an approximate boundary of the Bandelier East and West buildings here on campus at UNM, and then a line feature that represents a path from one building to the other. If we zoom out, we can see the imagery changing. And also you'll notice in this, I have restyled the attribution block and the mouse pointer block so that they're more visible and more contrasting to the rest of the map, so that they're easier to make out. But if we continue to zoom out, we can of course see my vector layers get more coincident with each other. But I can eventually zoom out to the point where if I turn on one of my layers, say the counties layer, this will retrieve the counties KML file from the server and then render it within the client. Now, one thing you should keep in mind as the page loads is that there are practical limits to the size of KML files that you should try to load into your map client. This particular KML file is almost 14 megabytes in size and is very complex. And as a result, actually forces the web client to work very hard to store the geometry and then render it properly within the client. So while I've used this as an example here, this is probably a larger KML file than you would want to use in any web application that you're using. I can turn on the states KML as well, which is not nearly as large as the counties one. We can wait a moment for it to load. While we're waiting, I will not load the city's KML file at this point because it is also a fairly large file at 7 megabytes. Again, not necessarily a file that you would want to directly use in your client, or not use without specifically defining some well-tuned strategies and scale limits to really only try to handle it in subsets. Here you can see now both the states KML file rendered and the counties rendered as a part of the map. And this is all happening on the client side. So these are data that have been retrieved by the web browser itself, with OpenLayers then converting those into geometry objects that are stored in memory and available for display. Again, highlighting the need to be somewhat careful in the size and complexity of the KML or other data files that you bring in to your client so that it can maintain reasonable performance. So let's look at the source code for this page so you can see the examples of first the set of geometries that I created and how that process worked, but then also the process for creating the additional KML files. So like our other client, we're bringing in the OpenLayers JavaScript framework as one script element here. We're then defining our next script element that contains, just like before, the real meat and potatoes of what we're doing in terms of defining our map. First, defining a set of global variables. In this case, including creating this new array called layers that I'm just adding all of my layer objects to so that I have a convenient container that all of my layer objects are a part of. And then starting with the initialization function here, the rest of the definition of our mapping client. The first step being the creation of our map object itself, where in contrast to our previous all default map object, in this case, since I was actually wanting to zoom in very closely at UNM, but I still have imagery for the entire globe, I decided to increase the maximum number of zoom levels to 20, as opposed to the default number of 16. This allows me to set my default zoom level for the map at 18, as you can see here, still allowing the user to zoom in 2 more levels, but also being able to zoom out to the entire globe if they would like. Here is our background imagery layer, which is essentially the same as our last example, so I won't go through it any further. This is again hidden within the layer switcher because we have this display in layer switcher set to false. But that is the base map that we're using for this. Now we have a series of steps associated with vector layers and adding them to the map. So first, I'm going to create a new layer that is just an empty container at this point. And I'm calling this layer local features, and it's a part of the array of layers that I created up above. So I'm just creating a new OpenLayers.layer.vector object and giving it the name my local features. This layer does not currently have any features in it. Nonetheless, I then add it to my map. So it is now a part of the map, so any features that I add to it will then automatically be visible within the map. Since I want to be able to differentiate my different feature types from each other, I have also created a number of styles using the options that are available and published in the OpenLayers Style API that I showed you earlier. And in this case, I'm creating a set of variables, each of which is essentially a list of name-value pairs that consist of those options and the values that I'm assigning to them. So in this case, this particular style is a variable called myRedPointStyle, where I'm defining the radius of the point as 12, the fill color as a shade of red, where the colors are specified in hexadecimal values. You will recall that from very early when we were talking about colors on the web. I'm setting the opacity of the fill at 0.5, meaning it will essentially be half opaque, half transparent. I'm setting the stroke opacity also to 0.5 so that the stroke around the edge of the point is also half transparent. I'm similarly creating several other styles, one called my county's style, my state style, my city's style, my building style, and my path style, each of which have a collection of values that are used or can be used to then modify the display of any vector features to which those styles are applied. So if we now look down and create some geometries and features, we can see how this plays out. Where first I'm creating a point feature, just like we saw in the example. So I'm creating this variable called coord underbar classroom, and it is a geometry.point with the x and y coordinates for that point. I'm creating a similar point geometry in a variable called coord underbar office. Now I'm creating a new geometry type of a linear ring, which is just a series of points that close at the end. So the first point closes with the last point, creating a closed polygon. I am assigning this to a variable named coord underbar building, and I'm just creating it by providing an array of individual OpenLayers.geometry.points. Very similar to what we did in Google Maps when we created any polygons, where you just basically define a series of points that specify the boundary or edge of the polygon. Finally, I'm creating a set of coordinates for a building path. So this is a linear feature, and so we're creating a geometry.lineString object where we're again specifying a series of points, but in this case, because it's a line string, they are not closed and connected to each other at the end. So the first point is not connected to the last point. It's just a linear feature that consists of points, where this is also illustrating the use of previously defined points for some of the point objects within this line string, where my line string starts with that coord underbar classroom object that I had previously created. And then it has two new points separated, all of these being separated by commas. And then finishing with the coord underbar office point object. So you can mix and match these. If you have existing point objects that you've created, you can use those in lieu of creating new point objects when you're creating these line string or linear ring objects. So here I have now created a set of geometries. So now I need to create a set of features that make use of those geometries. So this is where, in this case, I'm creating a new variable called point classroom. And I'm creating a new vector feature type where I'm specifying 3 values for that function. The first is the geometry, where you'll remember from up above that variable coord classroom is a point geometry object. Here, this null represents any optional features of the vector feature that I would want to specify. In this case, I'm not specifying any, so I'm just setting it to null. And then the third object is my style, where I'm defining the style of this particular feature vector object to my red point style that I defined up above, which again is just that list of name value pairs where the names are the style names from the API and the values are the values that I want to set those style names to. Similarly, I'm now creating a new variable called pointOffice that is another feature.vector object, where in this case I'm just providing the geometry using just the default values for options and styles. So I can just provide a geometry and OpenLayers will give me something. I'm now creating a new object called linear ring underbar building. The naming scheme that I'm using here is a reminder to me that what types of vector features these are, distinguishing them from the coordinate variables that I defined up above. So in this case, again, I'm creating a new feature.vector object, providing it the geometry coord underbar building, which was, again, if you'll remember, was this set of points here that defined a linear ring geometry. So I'm passing here essentially a linear ring with no additional options, but using the my building style for rendering that particular feature. Finally, I'm creating this variable line string building path that is also a feature.vector object that I'm providing that line string that I created up above called coord underbar building path, setting no options, but then setting it to my path style for how it should be rendered in the map client. I've now created these 4 vector feature objects, and now I need to add them to my layer so that they will actually be rendered. And that is accomplished with this function right here, where I am referring to my layer here, referring to it by name. You remember I created the local features layer up above as a part of the layers array. Here I'm retrieving that particular layer called local features. I'm executing the add features function for that, where I'm passing an array of all of those feature vector objects that I just created. This is essentially adding all 4 of those features to my layer so that they will then be rendered within the map. If we look back at the map, you can see, let's refresh this. You can see in the map here all 4 vector features. My 2 point objects, the line string object, and my polygon, all rendered using the styles that I created for each. Let's now look at the KML layers and see how that process works for them. And this is fairly repetitive, so I'll go through the first one in more detail and then go through the others more quickly. Where just as in the example that I provided a few minutes ago, we're creating for each of the KML layers a new layer object. in this case, again, we're adding a layer object to that array of layers, and that's this notation I'm using here, layers.states. So I'm creating a layer object called states within that layers array. Just as I showed before, I'm creating a new vector layer object, giving it the name KML states, specifying some options here. Again, these options are cumulative as you're talking about the options that are specific for vector layer types, but then also the layer object itself. So here I'm specifying the projection to the same projection as the map. I'm specifying the visibility as false. You'll remember this from our discussion of WMS layers, where this is where that visibility option can appear for a vector layer. So in this case, this layer will not be visible by default. Here I'm specifying the style. Again, I define the styles up above using those name value pairs for the styles. And then as we saw, the strategy for this KML layer is fixed, meaning we will load the entire KML file into the client and use it entirely within the client, as opposed to any sort of attempt to request any additional information from the server. Where for KML files, this is pretty much the only strategy you can use, at least as far as retrieving data from the server. You can use other strategies for rendering, but this is what you're stuck with for retrieving data from the server. And again, we have our protocol, where we're specifying the URL. This is again a KML file that is in the same directory as the HTML document that we're working with. So this simple pointer to the KML file is sufficient. If this file is located someplace else on your server, you would need to provide a more complete URL to point to it so that it can be properly retrieved. And then we're specifying the format as the KML format. Once this vector layer is created as a KML vector layer, we add it to our map using the map.addLayer function. We then repeat this process for the counties and the cities layers, where again we're creating a new county layer within the layers array. We're naming it KML counties. We're setting the projection and visibility as we did the previous layers. We're setting the style to my previously defined my counties style. And then we have our strategies and protocol, where again it's a fixed strategy, and in this case we're pointing to the NM counties KML file. And then we add this layer to our map. Finally, we add our cities, first by creating our cities layer object within the layers array. The name is KML cities. We have our projection and visibility, same as the previous layers. We set our style to my cities style. And our strategies and protocol again, where again the only difference is the URL where we are requesting the nmcities.kml file. When that is created, we then add that layer to our map. Then you can see here, we're then setting the map center as we've done before. And in this case, I've added two controls, the layer switcher and the mouse position. Also here, I have added two additional elements to our styles that allow me to reposition and restyle the OpenLayers mouse position and attribution controls so that they appear in a more beneficial way within the mapping client in terms of providing them with a background color so that they are visible, or their content is visible against the background image, repositioning them within the window so that they're pretty much in the lower left and lower right hand corners of this page, modifying the font size a little bit, and other minor tweaks. So these are an example of how you can use cascading style sheets as they discuss in the OpenLayers 2.10 text to modify your controls within your map client. And then we have the standard HTML down below within the body, where we just have some basic web content and our div with the ID set to map, which is the ID that the map object is linked to way up above in our map object creation here. So that completes our lecture for this week. Hopefully this has provided you with a new set of examples and a greater understanding of how you can start adding new layer types into your OpenLayers maps, keeping in mind that we still have only scratched the surface of the different layer types and capabilities of OpenLayers as another web mapping client platform that you can use for presenting geospatial data and information over the internet.